A black hole could pass through this room right now, and you'd survive. If you're expecting sci-fi explosions, leave now. This is real physics, and the reality is much stranger and much quieter than the movies. Gravity isn't suction. It's a curve. You fall only if you cross it, but you fear size. You think black hole means apocalypse. You see a monster that devours stars, so you assume a tiny one would devour you. You confuse heavy with hungry. Let's fix that. Take Mount Everest, roughly 180 billion tons of rock. Now crush it. Don't just shrink it, collapse it. Force all that mass into a space smaller than a single proton. To match this density, you would have to take every human being on Earth and crush them into a volume smaller than a grain of sugar. The mass stays the same. The size changes everything. Stand 10 feet away and you feel nothing. Your phone stays in your hand. Gravity weakens with distance. Unless you touch the event horizon, you are invisible to it. But don't get comfortable. Gravity isn't the real danger here. Heat is. We'll get to that. First, we have to drop it. Now, drop the proton-sized Everest. You expect it to eat the floor. You expect a hole. Wrong. You are forgetting how empty matter really is. Your floor looks solid, but that's an illusion. It is a wire mesh of atoms held together by electric fields. Let's visualize the scale. If an atom were the size of a football stadium, the nucleus, the hard part, would be a marble on the 50-yard line. The electrons would be gnats in the nosebleed seats. Everything else? Empty void. Our black hole is smaller than that marble. It falls through the stadium. It misses the gnats. It misses the marble. It slips through the void like a ghost. The chemical bonds holding your floor together are stronger than the black hole's gravity at this range. It doesn't rip the floor apart. It slides between the molecules. Even the concrete foundation remains untouched. The chance of a collision is statistically near zero. It accelerates. Gravity pulls it down. It pierces the crust and enters the mantle. It deposits a negligible amount of energy. It creates less friction than a subway's train. It's not eating. To consume, it must hit a nucleus directly. It's a sniper trying to hit a bullet with another bullet in the dark. Short pause, it shoots past the core. It flies out the other side, perhaps popping up in the Indian Ocean. It stops for a microsecond in the air. Then gravity snaps it back. It falls again. It becomes a pendulum inside Earth, oscillating back and forth forever. The Earth doesn't vanish. Calculations show it would take billions of years to consume even a kilogram of matter. The sun will expand and burn out before this black hole finishes its first meal. You're safe from the hunger, but here is the trap. The danger isn't gravity. It never was. It's thermodynamics. Pay attention. This is where physics gets dangerous. In the 1970s, Stephen Hawking proved a terrifying rule. Black holes aren't black. They radiate. They leak mass back into the universe. But here's the paradox. Massive black holes leak slowly. They are cold, silent. Tiny black holes leak fast. They are hot, violent. The smaller the hole, the hotter it gets. It's an inverse relationship. As it shrinks, it gets brighter. Imagine a candle that turns into a blowtorch as it melts. Our Mount Everest black hole is stable. It leaks slowly, but let's change the variable. Make it lighter. Make it the mass of a cruise ship. Now, the math breaks down. As it loses mass, it gets smaller. As it gets smaller, the temperature spikes. This causes it to lose mass even faster. It enters a runaway feedback loop. It is no longer a gravitational object. It is a bomb waiting for a trigger. The tiniest misstep triggers disaster. It doesn't eat the Earth. It detonates. It reaches the end of its life in a fraction of a second. This is pure mass to energy conversion. E equals mc squared. And M is a cruise ship. In theory, the energy release rivals a nuclear arsenal. It releases in a single nanosecond, a blinding sphere of hard gamma radiation. It vaporizes the crust for miles. It sends a shock wave that shatters tectonic plates. The atmosphere ignites and destabilizes. All of reality changes in a blink. Life ends, not because we were swallowed into the dark, but because we were flash fried by the light. Safety depends on one thing: mass. Heavy intruder passes harmlessly through the empty space of your body. Light intruder kills instantly. We exist in the lucky middle ground. Space might be full of these things, primordial remnants from the Big Bang. They might pass through you right now. You wouldn't feel them. You aren't safe because you are strong. We survive not because space is safe, but because physics is precise.